thanks everybody for joining the SPIA webinar today. Today we have Paola Mallia, who used to be a pre-doc at SPIA and is now a PhD student at the Paris School of Economics. After Paola's presentation, Kibram will provide some discussion points and offer a discussion, and then we'll have general discussion after that. For clarification questions during Paola's presentation, if they're really pressing, feel free to type those in the chat, or to come off mute, raise your hand, and we'll manage that. So that's that, and go ahead and take it away, Paola.
Thank you, Kyle, and thank you everyone for joining. I'm very happy to present this work that I started investigating basically during my pre-doctoral fellowship at SPIA, as Kyle said. And so today I'm going to be presenting first this working paper about misperception in varietal classification and the impact that this has on farmers' behavioral adjustments. And so, starting from a very broad motivation, so there is wide economic interest in the role of technological change to actually affect growth and climate change adaptation. And indeed, low adoption of agricultural technology has been believed to be one of the key reasons why sub-Saharan Africa has failed to experience agricultural productivity increases in the last 60 years, lower at least in comparison to the Green Revolution, for example, experienced in Latin America and Asia. However, recent assessment actually claim that while the use of inorganic fertilizers and agrochemicals remains relatively low on average, there has been quite a lot of success given the government efforts in stimulating the modern input use, and especially maize. However, unfortunately, these inputs are rarely used together on plots, despite there is widespread evidence of agroeconomic synergies. And so the literature focus has proposed and investigated different internal and external constraints that inhibit adoption of agricultural technologies and farmers from making this complementary inputs allocations that are needed with agricultural technologies. And so some of them are liquidity constraints, lack of insurance, present by naivete, lack of information. And here we try to propose a new mechanism, a new constraint that could be in place. Which is misperception, in which improved crop variety is being used. And indeed, there is growing evidence of this misperception that has been found in different countries and for different crops that ranges from around 36% to 70%. And so if we take the case of Ethiopia using the LSMS ISA survey 2018-2019, and if we define basically improved variety as containing CGIAR-derived germplasm, what we see when we compare basically an objective measure of crop variety identification and farmers' belief, we see that there is quite a mismatch. Indeed, according to farmers' reporting, we would conclude that basically improved varieties are adopted on 45.4% of the plots, while if we cross-check, if we check the objective measurement, we actually see that improved varieties are on 60.6% of the plot. And so the mismatch between, and so comparing these two different measures about the same thing, actually, we see that we have different categories that emerge across farmers, meaning farmers that are actually correct about their classification, whether improved or not improved, and farmers that are actually on this diagonal, you can see that they're not correct regarding their beliefs. And so the question we try to answer with this work is whether farmers' correct classification of these improved varieties actually affects the allocation of complementary inputs, agricultural practices, and consequentially productivity and profitability. In order to answer this question, I will be focusing on these two categories, which is basically, I'm going to restrict the sample to those farmers who, according to the objective measure, are growing and improved varieties. And this farmer, these two groups, the difference between these two groups lies in the fact that some have correct beliefs about the variety they're growing and some don't. So this 23.3 here has correct beliefs and the others don't. And so just to give you an outline of what I'm going to be exploring. So we estimate the effect of correct identification of improved maize variety in Ethiopia on inputs allocation, agricultural practices, yields, and profits. We provide causal identification using the rollout of a government program that increased the transparency in the seed sector, which is the direct seed marketing program. And we're going to do this through an IB approach. And then I'm going to try to address some sample limitation using machine learning techniques, meaning that I'm going to be predicting the objective measure of maize variety, which is available only on a subsample of the nationally representative sample. I'm going to predict this using self-reported data, and I'm going to extend my analysis, which will allow me to extend the analysis to the nationally representative sample. And so the contributions of this work are at least four. So I'm going to be providing causal evidence that farmers who correctly classify improved variety do exhibit a behavioral adjustment in this production decision. And in particular, I'm going to be trying to quantify the cost of having incorrect beliefs, which provides a potential explanation for resource misallocation, meaning that what I'm going to be trying to show you is that farmers are actually optimized, in case of misallocation, farmers are actually optimizing the wrong production function rather than failing the optimization problem. I'm going to be providing some suggestive evidence of the dynamic nature of farmers' learning about agricultural technology, given the fact that my instrumental variable is basically informed by the length of exposure to a program that should increase the transparency and thus making farmers learn more about which one are the improved varieties. And then we provide basically we developed this interpolation model to scale objectively measured data. And we try to show that basically the implication of measurement error can go beyond statistical inference. And so the data I'm going to be using, I use the Ethiopia Socioeconomic Survey, where basically farmer self-reports on variety are asked, but also there is an objective, it's being collected an objective measure of varietal identification, which is the DNA fingerprinting measure. The limitation of this data are, for our analysis at least, are two. So the DNA fingerprinting was collected on a subsample of plots that is representative of maize growing region. So it's not collected on the full nationally representative sample. And the second kind of limitation is the fact that it's not a panel, but we can, however, still make use of the previous waves that are panel for robustness checks. In addition to this, I'm going to be using administrative data on the rollout of the direct seed marketing program, and I'm going to be considering other programs of the government, such as the input voucher sales system, agricultural commercialization cluster, and maize suitability for land. And so before we start talking about the empirical strategy, so just to understand where is our variation coming from. So the Ethiopia seed system up until 2011 has been highly centralized, where basically the seed supply unfolds along a very, very long chain of government offices. And so where basically seed enterprises, meaning those who actually produce the seeds, do not have any contact, any direct contact with farmers. The novelty of the direct seed marketing program is that it allows producers to market their seeds directly to farmers. And so the rollout of this program started in 2011 and now covers Amhara, Oromia, SNNP, Tigray, and Tigray regions. And so why is this program interesting, let's say, for our analysis? That basically the competition between these different suppliers calls for transparency in both in the characteristics of the seeds that are sold, but also it kind of creates a system where farmers tend to learn about which are the trustworthy actors involved in the supply chain. And so this competition calls for transparency in order to gain market share among farmers. And so I'm going to be exploiting the length of exposure to the DSM program as a proxy for learning about varieties that are available on the market and which one are the trustworthy actors involved in the supply chain. And so this is a very, let's say, complicated scheme about what's going on between the two programs. So on the left, you see the conventional seed marketing, which is what is the status quo, let's say the conventional seed supply in Ethiopia. And basically what you see is that seed enterprises are here and have no direct connection to farmers, while basically the farmers are connected through all of these government offices to get both the seed demand assessment and the seed supply. With the direct seed marketing on the right, what you see is that seed enterprises now have a direct link with farmers. And so this is the link that calls for competition, basically. So the rollout of the DSM program is not random, and it's at the varietal level, and again, goes from 2011 onward. However, basically we know from qualitative interviews with farmers that exposure to beta seeds is also a function of distance to varietal town. And so we're going to be using also this source of variation in our instrumental variable, which is going to be the years of exposure to the DSM program and how proximate households are to varietal towns, meaning to mostly the nearest urban centers. And I'm going to be, and while I do this, I'm going to be controlling for land suitability maize cultivation. And so our empirical strategy, as I mentioned, is an A/B strategy. And so our first stage, we try to predict correct identification using these two sources of variation that I was telling you about, which is basically the interaction between the household proximity to our data center and the direct seed exposure to the direct seed marketing program, while I control for other programs, governmental programs that are in place at the same time. It could be confounding this effect. And and so given this first stage, I'm going to be using this first stage to actually say something, estimate the impact of this correct identification on a number of outcomes, which are going to be input allocation, agricultural practices, yields, profits at household level.
Paola, could I just ask a question so that I'm familiar, so I'm up to speed with what you're doing? If you go back to the first stage, there. So you're comparing people who are closer and further to the town, essentially, differentially between varieties that do and do not have the direct seed marketing program. Is that correct?
Yes. So yes.
Okay.
Yeah.
No, I just wanted to make sure I'm understanding sort of the thought exercise correctly.
Yeah, so it's not going to be just about how much your variety gets exposed to DSM, but also how much you are distant, so the differential distance to urban centers. Because what we expect is that basically what I'm going to show you is that basically the DSM program is going to have a bigger impact for those people that are more remote, for remote rural areas, because the people that are the farmers that are actually in urban centers have a better chance of engaging with seed suppliers. directly, while basically remote rural areas will need to rely on those seed suppliers that will make the last mile of the distribution, right?
Okay. So I think that intuition is useful to kind of bring out when you present the equation to say why you think that it should be that differential effect.
Okay, yeah, I was gonna discuss it here now that I'm in the
cool. Thanks, Paul.
In the first stage. So our so this is our first stage. So I'm using my instrumental variable to predict correct identification, and so we see that the effect is strong and negative. And so again, it goes again in this direction that basically the DSM program has a bigger effect as more predictive power on correct identification whenever farmers are not proximate to urban centers. And so this our first stage explains the variation that it explains is around 27%, and given this F statistic, we shouldn't be too much worried about weak instrumental variables. And so the first thing that I'm trying to convince you, I'm going to show you is some additional checks, so that basically our instrumental variables just predictive of correct identification, but not other things. So you might be indeed worried that it's predicting just simply that farmers believe that they're going an improved variety. However, whenever I do this exercise using as an outcome variable improved variety, the instrumental variable is no longer working, it's no longer predictive. The same happens if I instead use the objective measure. So the instrumental variable does not predict being an improved variety from the DNA, from an objective perspective, while it is predictive even when I consider basically true positive and true negatives, meaning farmers that have correct beliefs, both of growing an improved variety, or they have correct beliefs about growing a traditional variety. And this is the last column here. Okay, unless there are questions, I'm going to be moving to the stage.
So Sujata has one here. Sujata, did you want to come off mute?
Thanks, Kyle, and thank you, Paula. I think you may have just answered my question. So you're saying that it doesn't change which variety they use, it changes whether they know which variety they use.
No, what I'm saying, I mean,
right?
What I'm trying to show you is that it's predictive. The instrumental variable is predictive of correct identification, whether you are correctly identifying an improved variety or whether you are correctly identifying a traditional variety, meaning improved or not improved. So it's just to say that it's a transparency effect rather than it's picking up something else that we don't actually want to be picking up.
Okay, yeah, and also I think your column 2 is saying it doesn't change which variety they actually are using, right?
It's just saying that whenever which improved variety they're using. Yes, exactly. In some sense, yes, but it is mostly to stress the fact that it's not just an effect coming from basically the market being flooded with DNA improved variety from the objective point of view, and so that the instrumental variable is just capturing that, so that there are more improved varieties, and so that the program is doing that. And I don't know if you see what I mean.
Yeah, and I think Kyle is following up on my point, and yeah, that is what I was wondering about, but I get the feeling that column 2 and column 3 put together probably are suggesting that we don't need to worry about the exclusion restriction.
Or at least
we can come back to this later if you like, Kyle.
Yeah, that sounds good. Thanks.
Okay, and so looking at how our so what is the effect of correct identification on inputs use and plot selection? So what we do see right away is that farmers that correctly identify the variety as improved, basically apply 164 kilos per hectare of urea more, no effect on DAP, and another strong positive effect on DAP, on MPS. And so although the survey instrument doesn't tell us exactly when these fertilizers are applied, given the fact that these different fertilizers do different things, we can kind of see that, and in particular, urea is usually applied after germination, while MPS is applied before germination of the seeds. We can see that farmers are basically making investment whenever they're correctly identifying, they're making investment both before and after germination, suggesting that they're not afraid of making early investments. We do see an effect on hired labor at harvest, which is consistent with the fact that their farmers are growing an improved variety and yield enhancing variety, but also that they're applying more fertilizers. And also we see that the seedling rate is actually, the effect on seedling rate is negative and statistically significant, which kind of suggests that farmers are quite confident about the quality of their seeds, and so they don't increase the quantity of seed applied on a plot just to increase the probability of germination, but instead they're basically actually reducing it. And so in terms of the deviation from let's say the enumeration area mean in terms of plot potential wetness, plot elevation, and plot slope, so meaning plot characteristics, given that these farmers are actually have at least 3 maize of plots, they can also basically select the plots based on their characteristics, and we see that basically they tend to choose plots that are less that have a less elevation. Moving to agricultural practices, so here I'm looking at a number of agricultural practices, such as rotation with legume, crop residue cover, minimum tillage, etc. And so here I don't find actually an effect on any of the practices. Not even the factor index actually shows an effect, which is basically the combination of all the practices that I'm using. Doesn't show an effect. Next question I'm trying to answer is whether basically these additional inputs that farmers apply on their maize plot whenever they have a correct identification of the variety, whether these inputs are coming from plots cultivated under other crops, so whether there is a reallocation from other plots, or they're actually crowding in inputs. And so to do this exercise, I'm basically collapsing everything at the household level, and I distinguish between plots under maize cultivation and plots that are under any other crops cultivation. And here the assumption that I have to make is, since I do not have the objective measure for every plot that the household cultivates under maize, I have to make the assumption that basically that the same maize seed is used on all the household plots. And so to see this, so I'm reporting again the third stage at the household level this time, and it's actually stronger than at the plot level. And so the panel B is showing us, shows basically plots under maize cultivation, while panel C shows all plots that are not under maize cultivation. And so what we see here is that, if anything, the effect, I mean, farmers are not crowding out from these plots in favor to maize cultivation, but instead they're crowding in inputs also for those for plots other than maize. We see this effect both on urea and MPS at least. And so having observed all of these changes in inputs allocation, the next question that it's interesting to try to answer is whether this has an effect on yields. And we see that those who correctly identify the variety are actually experience a huge increase in yields, which accounts for 140%. And this is consistent. The magnitude is kind of consistent with both the fact of growing an improved variety, again, that is yield enhancing, and with the magnitude that we found on the input use, on the fertilizer input use. When we look at maize profits, I mean, all the profits that are coming from only maize cultivation at the household level, the effect is not statistically significant, although it's positive and quite big in magnitude. And it has to be noted that, I mean, it might be that we don't actually detect a statistically significant effect due to the fact that the measure is quite noisy. So moving on, so far the limitation that I have is that the fact that DNA fingerprinting, as you saw, was collected on a subsample of the naturally representative sample, and so it kind of limits my statistical power. And so I use machine learning techniques to replicate the same analysis to the naturally representative sample, and also to develop a model that interpolates objective measure from self-reported data, given that objective measures are very difficult to scale at the natural level. So I used 120 covariates to predict DNA fingerprint, to predict the DNA fingerprinting measure. And it's important to note that here, whenever I'm doing the prediction, I'm not using any of the variables that I've shown you so far in the analysis, of course. And so the machine learning model, I'm going to be using basically the usual suspect in classification problems. And it's going to be an ensemble method of this. My training sample is going to be 491 observation. We use 5-fold cross-validation, and we reach an accuracy of 85%. And so I use this to predict on the remaining 1,460 observations. And so what I'm going to show you now is basically I replicate the analysis, but this time instead of using the actual observation, the actual variables that I was using before, I'm going to be using the prediction that I've obtained from this exercise. And in order to understand what's going on, I'm going to be showing you first the results using the predictions of the original sample, meaning those same plots that I was showing you before, where the DNA fingerprinting is available. But instead of using the DNA fingerprinting, I'm going to be using the prediction that I calculated. And then I'm going to start enlarging my sample to include basically all the farmers that were in the same EAs that were sampled for the DNA fingerprinting exercise. Then I'm going to be enlarging to all the farmers that were in the same regions of my original sample. And then I'm going to go to the fully nationally representative sample. And so here I'm showing you again the first stage. And so the first column is basically it's always the predicted values of the original sample. So basically the same number of observations that I was showing you before. And we see that the instrumental variable is still relevant, although slightly the F statistic is slightly lower. When I move when I start enlarging my sample and including all the farmers in the same EA, again, our instrumental variable is still robust and consistent. While basically when I move to the same regions and food sample, I start losing a bit of power. The instrumental variable starts losing a bit of power. And here, there are many reasons why this could be the case. And so one of them is the fact that I'm including areas that start where basically maize cultivations are becoming less relevant. And so for this reason, the DSM program was actually not rolled out. And so this is why basically my instrumental variable starts to have less predictive power, which is going to have implications, of course, for the two-stage least square. And
could I just ask a clarifying question, Paola?
Sure.
the sample that the fingerprinting was done on, the 313 or the smaller
yes.
sample, 313. Yes. I guess, how was that sample, you may have said this and I missed it, how was it selected, and was it's certainly smaller than the whole sample, but was it randomly selected? And
yes, absolutely.
are we really thinking that, like, okay, so it's just a random selection?
Yes, yes, I should have said that.
So there's no reason to think that the point estimate you get out of that, other than just maybe being slightly less powered, is not representative of the country as a whole.
The thing is, it's randomly selected at the EA level, but out of the regions, there are mostly relevant for. So it's not nationally representative, but it's regionally representative. That's the issue that I'm trying to address. It's regionally representatives of those regions where maize is relevant.
Okay,
so moving on to I'm showing you here in the paper there, the actual, here I'm just selecting where those coefficients where we find more variation. And so as we go from panel A, which is the most restrictive sample, and we move to the full sample, we see that both urea and NPS remain quite consistent across the different samples, and also higher labor, while we only lose significance basically in the seedling rate. So the only result that doesn't really hold across the food sample is the seedling rate. And so to conclude on this work, so I try to show you that basically correct identification of the improved variety grown leads to large increases in fertilizer use and hard labor. We find evidence of farmers crowding in resources rather than actual reallocation from other plots. We find no impact on agricultural practices, and we see large increases in yields and potentially large increases in profits, just not statistically significant. And so the implication of this work is that basically misperception in which agricultural technology farmers are using has actually testable consequences for the production decisions that are made. And this is particularly important, becomes particularly important given the fact that most of the new, it's very more and more often, new varieties are actually bred with climate-resistant traits, which require efficiency resource use and are actually adaptable to climate-smart practices. But again, if you are misperceiving those traits, it's unlikely that you will adjust and adopt also those practices. Should I stop if there are questions before we move to?
Why don't we go directly to the discussion with Kibram, and then we'll do a sort of broad question and answer session after that. Is that okay?
Yeah, sure. Otherwise, we'll outline, because moving from here, I was going to outline a research design too, but.
Oh, I didn't know that. Sorry. No. Veto what I just said. I didn't know you had a new another plan. So you're in great shape. Go continue. I apologize. All sorts of issues on my side today. I apologize. Go ahead. Sorry, Kibram. You have to wait.
So given this evidence about farmers' behavioral adjustment whenever there is correct identification, and so what are the cost of having incorrect beliefs. So next thing that I wanted to present you and get your feedback on is a new research design. It's a new research idea that I'm trying to develop during this PhD. And so far, basically the quasi-experimental evidence that I've shown you has the limitation that the estimated effect is a local average treatment effect, like every ID. meaning that this effect of correct classification are for farmers who are exposed to the DSM program conditional on their distance to urban centers, and actually end up identifying the variety grown as improved when this is the case. And so as a next step, given the evidence of this farmers' adjustment in behaviors in production decision, the next step would be to provide actually experimental evidence of what is the effect of actually correcting this misperception. So far, I've been talking about misperception in improved varieties, but it would be also interesting to know whenever what is going on whenever there is misperception in traits such as climate resistant, virus and pest resistant, etc. And so, oh, sorry, this is very small. I apologize. I should have checked better. And so, the theory of change of improved crop varieties is very simple, right? In some sense, you have you first have the breeding, then the variety gets released, then these new varieties get diffused in the countries among farmers. Farmers get exposed to these new varieties and decide whether to adopt or not adopt, and they make the decisions about complementary inputs and agricultural practices, which leads to impacts. And so what I've been showing you is that actually this theory of change that is very simple kind of breaks down whenever the assumption that there is no misperception in variety and or traits holds. And so we see that, and so what we have seen is that basically the complementary inputs and agricultural practices to be made, there has to be no misperception in some sense. And so the research questions that I'd like to answer with a new experimental design would be whether there is misperception not only in which variety you're growing, but actually in the traits that each variety has. I'm going to be more specific in a second. And if there is misperception, do farmers update their beliefs when correcting this misperception or misinformation about this trait? And whether this belief updating, if possible, if farmers can update their beliefs about it, about the traits, does it lead to changes in production decision? And the idea is to try to answer these questions through an RCT, where where the treatment consists of providing correct information to farmers. And so we move from the context of maize in Ethiopia to sweet potato in Uganda. And so there has been a large effort to disseminate planting material of modern varieties across Uganda, among which also sweet potato. A large set of actors have been involved in this, including Harvard Plus, SPIA, the government agencies, etc. And basically, in 2010, there has been launched the DIVA project, meaning diffusion and impact of improved variety in Africa, which aimed to document diffusion and adoption of modern varieties across sub-Saharan Africa, and in particular in Uganda has been found the survey showed very low adoption. And now, basically in 2022, SPIA and SIP collected data on adoption, both self-reported and objectively measured on sweet potato in the same sample as that is the DIVA project. And so this sweet potato that I have at least so why do we care about these sweet potatoes? Because they have at least two traits that are very important. One is the nutrient enhancement, meaning they are either orange or yellow flesh sweet potato, and have the nutrient enhancement is about vitamin A content. And so what we see that basically, given the trait, it's visibly recognizable given the color. We see that we can kind of expect the misperception should be less of a concern given this signal, while actually the knowledge of the nutrient content could affect actually consumption decisions. The second trait that is particular about the sweet potatoes that have been disseminated is the SPVD resistant trait, so it's the virus disease. And this trait instead is not observable, while it should impact also production decisions. And so as we see, as I'm trying to schematize here graphically, what I'm going to be talking about is that basically, so from the variety name, so each variety should have some particular traits. Knowledge about these traits should influence other agricultural practices that are adopted by the farmers. And so what I'm trying to, what I aim to do is whether basically to understand whether these variety names actually predict knowledge about the traits, first of all. And then I'm going to be looking at whether when there is or there is not misperception about the traits, correcting this misperception, does it lead to different agricultural practices adopted? And so,
Paula, if you could take maybe about 5-10 minutes, 10 minutes or so to sort of take your last thoughts. We'll hold all questions until then, and then we'll leave time for Kibram and then a discussion. Is that okay?
Yeah, I'm done. Yeah, just cool. Okay, so just to show you some preliminary evidence that we can look at by that we have found exploring basically the survey data that's been just collected on sweet potato. So we find that farmers actually report around 2,900 different variety names, which is way more than actually probably what has been released, because farmers use a number of local name that it's huge, and so it is interesting to understand how much of those names actually can predict knowledge about traits. Second thing that we start finding is whether that farmers are basically misreporting traits for the same variety name in the same survey, meaning a farmer reports for one season to be growing one variety. We ask what are the characteristics of this variety, and then we ask it again for the next season, and we see that basically 24% of farmers actually misreport the color of the variety across the same survey, and 50% actually do the same for SPVD trait. It would be great to look at misperception by comparing again the objective measure with farmers' belief. However, this is not possible for now because we still are waiting for the results of the objective measurement. What we can do instead is basically comparing farmers' reports, farmers' belief, with the community survey, the information contained in the community survey, assuming that basically community leaders are more expert than farmer in knowledge about these varieties. And so what we see here is that there is error. 33% of farmers actually disagree about the color of a specific variety with than community leaders. And it's even bigger if we look at the SPVD trait, meaning that only that 68% of farmers don't report this trait, while community leaders do. Okay, and so what are the treatment of this potential RCT? So the first treatment would be to provide actually the correct naming of the variety to farmers in order to understand whether, and so we would have basically different groups based on priors. One group where we basically confirm potentially the correct naming of the variety if they were correct about it, and another group that's where we correct actually a potential wrong naming that they're using, and this could tell us whether basically changing the name, correcting wrong naming actually causes changes in the knowledge about the traits. So whether you're more likely to report correct traits given correct naming. second treatment would be to try to correct what happens when we try to correct misperception of the virus-resistant trait. And here would be the treatment is about revealing the result of the objective measurement of virus-resistant trait collected in the last agricultural season to a random sample of farmers. This way, the idea is that they could update their prior beliefs. And so based on these priors, we would get 4 groups. Those farmers who were actually correct in their understanding in their perception about the virus-resistant traits, which are the true positive and true negative. In this case, they would just obtain basically a confirmation. While for false negative and false positive, we would basically contradict their beliefs. And so the idea is to observe whether there is an update in those beliefs and whether we observe a change in the response in the next agricultural season in terms of practices. And these are some potential outcomes that we were thinking. So for example, whether once you update your beliefs about the traits of the variety you're growing, you continue adopting or start disadopting in the next agricultural season. The amount of land you dedicate to this cultivation, to sweet potato cultivation, given what you've learned, whether you diversify both in terms of crop or just the variety, given that you are now, for example, that now you just learned that you are growing a virus-resistant variety, you might be decreasing, for example, how much you diversify your varieties because you're confident that it's not going to be affected by virus or diseases. And then labor allocation and how much you distance yourself to neighboring plots. The third treatment instead is about providing information on the nutrient content of orange fleshed and yellow sweet potato. And again, instead of correcting a misperception, in this case, it's actually about giving more objective information and observe whether this makes any difference in terms of consumption decisions. And so just to give you an idea of how this intervention could potentially work. So we collected data of season 1, we collected data of season 1 and season 2 in regarding the year 2021. We just finished the data collection. And so while the idea would be to wait for the DNA fingerprinting results, the objective measure results, do this intervention, then observe what are the changes in behaviors in the season 2 in 2022. Of course, this is a very tentative timeline, but just to give you an idea about what is the pace at which things should happen. So just to conclude, so why should we care about this type of misperception? Well, we've just, with the quasi-experimental evidence, we've seen that farmers' misperception distorts production and consumption decision, which will in turn affect the probability and the decision to adopt or disadopt these improved varieties. And this could ultimately reduce the impact of breeding programs. And so providing insights on how to correct farmers' misperception can help basically in making the theory of change that I've shown you at the beginning actually leads to the program, to the planned impact. And I'm done. Thank you.
Thanks, Paula. Now we can go to Kibram Mabai. So Kibram, go ahead. I think you should, Paula, you'll need to stop sharing. And then I think, Kibram, you should be able to do so.
Okay, so let's see if I can share my screen. Okay, can you see it?
Yes.
Okay, great. Yeah, thanks a lot, Paula. This is very interesting work, obviously, and very close to my heart and to what I have been doing recently. let's see. Yeah. So yeah, just to summarize, I think this paper aims to quantify the impact of farm misperception on input use, farm management decisions, and agricultural productivity. And the paper uses an IV approach that takes advantage of the rollout of a government program, the DACM program, that increases transparency in the seed sector and seed system. I think there are some key messages, and I think one of the key messages that the paper sends is farmers who correctly classify or identify the nature or the type of their inputs are more likely to adopt more inputs or more complementary inputs, and also they are more likely to get a higher yield. This is a major result, and of course, I think this can be unpacked in different ways. But one way to think about this is addressing information asymmetry or misperception can improve technology adoption as well as yield. So this is the broader message that Paola is trying to send. Obviously, I think this is very interesting and very important, of course, because we know that technology adoption remains quite low, or at least very heterogeneous and stagnant enough in many parts of Africa. And one explanation for that is the lack of information, lack of accurate information about the nature of inputs, and partly because farmers act on this inaccurate perceptions or misperceptions. And any uncertainty associated with the quality and nature of products can affect farmers' technology adoption. So overall, I think the paper is well motivated and it's properly executed. I think I like the way you positioned it with the literature, and I also like the context that you cover a lot. And most of the limitations are related to the data and sample size are also properly described. And I think I can also think of, I think most of the threats to identification and to exclusion restriction had also been described in the paper. I mean, there are obviously limitations to how much you can do with the data you have, but I think I like the way you try to identify some of the threats to identification. And I can think of, I think you did quite much of the robustness and placeable exercise that I was thinking, including using the data from the third, the second, and the first round of the ESSE data. So here I have some additional thoughts and questions that may relate to data and identification. One is obviously, as you continue to restrict the sample because you want to compare, now you're comparing people with the same technology but with different perception. They have the same improved variety, but the only difference between these people are the perception that they have. One of them knows that it's improved, one of them doesn't know it's improved. So this gives you a bit of internal validity, but it also, you are also imposing a lot of restrictions on that. And that means the sample size is getting low, and that also may affect your external validity. I mean, I recall that there are, I think, I was also wondering why you are focusing on maize. I don't know why barley cannot be part of the analysis. At least, I mean, I recall that there was some misclassification in that variable too in the data. Secondly, I also thought that the results at the intensive margin could also be, at the extension margin could be also interesting, because when it comes to input complementarity, in this sense, I think I would think that the immediate thing is whether a farmer applies fertilizer when he thinks that he has improved seed, or the other way. So I think adding the extensive results could be a good exercise. When it comes to the instrument, I mean, I can see there are colleagues and some of my co-authors who can add more to this, and I will be very brief on that. But I think the immediate thing that came to my mind is that the rollout of the DSM is likely to be correlated with ag potential and accessibility. The government is likely to be prioritizing those districts or woredas who may be characterized by high ag potential and accessibility. But I think, I mean, you're doing a lot of things along that. And I think what you showed us today, including showing that the instrument is not predicting access or usage of these products is very important. And I think I encourage you to expand that a bit, including using showing how the first stage behaves when you use the data from the second and the third round or the first round of the LSMS data, because we have that data. I was also wondering to see if, and I think, I don't know if this can be shown in the data, but if there are some community level information on access to seeds, then I think we might get you might get a sense of how the DSM had affected some of the factors that may matter for this. And then third, I think I also liked your oilless results, and I was thinking you're just skipping them, and if I were you, I would try to interpret them a bit and characterize the direction of bias that we expect in these coefficients. And then, because I like them, I mean, they seem supporting your IV results, and I felt I would discuss them a bit. And then, so you at some point you said that the DSM is generally meant to improve the transparency in that seed system. If that's the case, then I was also thinking comparing true negative and false positive. Like now you're comparing true positive and false negative. How about doing the other way, where you can also show if the results hold? Because I mean, these people have also the same technology but different perception. So in terms of interpretation and policy implication, I think I felt some of the IV results are very large. I mean, like you can see the yield effect. I mean, it's about 150 or something. Like this means that I mean I don't know the literature on returns to knowledge or returns to correct perception, but I felt that these coefficients are very large, and they may you may want to think about and perhaps interpret them. And again, I also think suggest you add the oilless estimates and then compare them and see where the oilless estimates are likely to be heading. And in terms of interpreting the results and the major policy implications, and I think especially if we take the strong sense of causal effect, then I think you have far-reaching implications that you can interpret them a bit more. Like, because what we are saying is improving rural farmers' access to accurate information about the crop variety they are growing can improve adoption of technologies. And I think this is an important finding, given that there has been a lot of investment to improve the diffusion and adoption of agricultural technologies in Africa. You're also showing that these additional input allocations are yield enhancing, and this is also interesting, and probably I think deserves more interpretation and perhaps more highlighting. And then finally, I think you're mostly I know you're mostly focusing on the behavioral implications. Because you are assuming that everything is misperception, and I think I agree with that. I think most of the misclassification that we see in crop variety is driven by misperception. And we have a recent paper showing that, which is forthcoming in the Journal of Development Economics. But But I think that also means that there is some implication for statistical inference, especially for people who have been interpreting this as just a misclassification, as an econometric problem where we can just treat it by using objective measures. So I don't think you want to focus a lot on that, but just on the way and on the passing, you could say that had also an implication. And this is also related to the story of complementarity, where people have been arguing that whatever we see in terms of complementarity is informed by perfect information and it can be yield enhancing. But that's not the case based on the results you have. It's because some of these complementarity estimates are driven by farmer perceptions and they may not be yield enhancing. Finally, your new research design address most of the concerns that you have, mainly in terms of identification, and I really like the new design, and yeah, I look forward to hear more progress on that. Thanks.
Thanks, Kibram.
Thank you so much, Kibram.
Yeah, Paula, that was a lot of comments, and so obviously it's we're not going to expect you to respond individually to those. I think we only have 20 minutes left, and so if you want to during the discussion circle back to some of those, please feel free to do so. But hopefully we can open it up for a more broad Q&A session and discussion, if that's okay.
Yep, sure, of course.
Cool. Then everybody, please use the raised hand feature. There's quite a bit of stuff in the chat, and if I could, Berber, you had mentioned something that I think would be worth circling back on. If you're still around and able, could you bring up your question?
Yes, definitely. So I mean, first of all, really interesting work, and I'm also really looking forward to see what comes out of the experiment. My question was around, this seems to have important implications, but I'm wondering, how could we scale a policy around providing farmers with information on the traits that actually are in the varieties that they're using? And so, which actors in the seed system would you think could take something like this to scale? Which types of private sector or public sector organizations would you be looking at to kind of scale something like this?
That's a very big question. To be honest, I mean, I haven't really thought about which specific actors could be involved. I think here to give you a more accurate answer about this, I think I'm not probably the right person to answer this question.
One possibility might be, ministries, agricultural ministries could be involved in something like this. Seed companies who are buying seeds from seed growers could want to do something like this in terms of scaling. I mean, those are two things that come to my mind. I'm sure there's probably more.
I'm going to channel Julius Okello here, who's involved with the sweet potato work in Uganda. And so he actually this morning was kind of making a point that when the sweet potato varieties are released, for instance, the variant-resistant threat is not something that's advertised. And so there may be, that's an interesting hypothesis. Like if some of this is what is the information that goes with the varieties and or are the names of varieties informative? There may be some higher order type of, of things kind of up the chain that are potentially interesting, that doesn't require a huge coordination campaign.
Right, and I'm also wondering how to scale something like the DNA fingerprinting. I think in more developed seed systems, this is actually something that seed companies might provide as a service to farmers, that they can take samples and get information. And certification is also, I think, important to consider there. But this is really interesting work. And the reason I'm asking it is because I would see something like this being tested at maybe more of a policy level, and us taking this on in future initiatives that we're developing around accelerating varietal turnover.
Yep. I actually probably don't think that it has to be scaled all the way. Probably there are some specific point along the chain where this DNA fingerprint, where objective measure can be collected just for quality assurance. And so, but I think we need way more research on this to understand which are the bottlenecks along the chain that actually could be more important to tackle for the objective measures.
Okay, other questions? Sujata, you just put something in the chat. Do you want to follow up on that, and then some of the other questions that you had during the presentation? Oh, Sujata, you're on mute.
Thank you, Kyle. I'm just puzzled a bit about treatment 1, and if actually, I think it's more of a clarification. Are you assuming that by telling farmers the correct name of the variety that they're using, they're going to be able to figure out what the correct traits are of the variety that they're using? Or is that something you are trying to find out?
Yes, exactly. This is something, I mean, that would be good to explore, given that there is a variety of, there is a huge number of names for same varieties that are actually spread among farmers. And so what we would be trying to understand is whether the variety name has any potential signaling, means anything from a traits perspective. So whether correcting this wrong naming or imprecise naming actually reveals that farmers still have correct knowledge about the traits. So I mean, your intuition was right.
Okay, but I mean, but if there are all these different names out there, and you tell them what the correct scientific name or the correct brand name of this variety is, I mean, I find it very plausible that it makes no difference whatsoever to a farmer.
Yeah, I understand. Like not exactly like the scientific name may have very it might be very not meaningful for farmers. What I'm trying to say is like what is the most meaningful name for a variety, so that whenever farmers actually go to the market and actually use the correct naming, you actually get the correct traits that you were expecting.
Okay, yeah,
I think
that helps. Yeah.
For me, it would be useful to start with like, okay, suppose there's a basket of varieties that a farmer can choose from, and I think there's an assumption that the marginal product of inputs, different inputs, varies across those varieties. How much does it vary, and what are the kind of actions that a farmer who's optimizing should take when they see that like they have variety X, like, oh, variety X, the marginal product of fertilizer, say, is 3 times the case in variety Y. And so knowing how much the marginal return to various inputs or management strategies varies across varieties, I think is a really good kind of launching point for this type of intervention. And then also, how much do farmers recognize that? And because I think, per Sujata's point, they need to kind of recognize that and know that in order to act on it, I think. So some sort of early sort of data to motivate that, and the sort of gap in the marginal return inputs across varieties would be really, I think, great.
Yeah, I agree. I also, I mean, I think there is this concern as well, right? That they can then change the variety that they're using. And so is that one of your outcomes? I mean, you said adoption and disadoption, but I wasn't clear if that was adoption and disadoption of the same variety, or, you know, they might just change which variety they're using because they realize the one they're using is not high yield or whatever.
No, definitely changing the variety use is also a super interesting outcomes. So basically, this is also something to include. It's not only about the adoption of the same variety, but it's definitely a meaningful variation if you change based on the information you have received. So definitely this is something to add.
Right, but then if your research question is about understanding what is the impact of knowing which variety you're using, or what the traits of if your question is about correct identification, then you now have a problem, right? Because now in the process of telling them what the traits are, you've changed their knowledge about the traits, and you've also changed which trait or which variety they're using. So I think you need something clever if that is your goal, you need something clever to separate these two things out. Yeah,
that's an excellent point. Thanks.
Okay, other questions that people have? We still have a few minutes. James, go ahead.
Sure. Paola, congratulations. It's very satisfying seeing all this come together in the Ethiopia papers. Delighted to see it. Just a quick point about the difference between the Ethiopia context and what you're now doing in Uganda with regards to the crop in question, right? So with and this kind of comes back a bit to there's some work that Kibram and Hope and I are doing on a review paper on some of this stuff around the behavioral implications of misperception more broadly across agricultural inputs. There's an asymmetry here that when you have when the samples that you were using in Ethiopia were from a crop cut, right? And you had a purity estimate and you imposed a threshold, but you knew from a population what was in that plot, from a representative sample within that plot, what was there. When you're sampling sweet potato in very genetically mixed fields in Uganda, you're going to encounter a lot of intraplot heterogeneity, right? And so my question a bit for this whole measurement agenda there is the within plot sampling strategy that you guys are planning is something I'm scratching my head about right now for each of the crops we're working on in the companion piece to this and with the UNPS. But do you want to just comment on that, about how you guys are thinking about sampling from what is almost certainly going to be a genetically mixed plot of individual clones of either intentionally planted or unintentionally mixed up in the process, is my first question. And the second is this question about the names and the names mapping to genotypes is asymmetric with regards to the situation in improved varieties, where you probably have a known genotype with multiple names, right? As opposed to local varieties where the scientists are always constantly trying to work out what is this thing. It's a moving target, and this, by definition, this is a farmer managed genetic resource. And so what's your thinking there about, does this information treatment apply also to local varieties, or are you just going to focus on the improved varieties in the experiment?
Oh, thank you, James. So regarding the first questions, if I'm not mistaken, actually for the DNA fingerprinting part of leaf samples of sweet potato, actually there are different samples that are being taken from each plot. But Karen, feel free to jump in if I'm mistaken in this. Regarding your second questions, the idea is that, of course, if there are I think there are too many varieties that are traditional, and so it would be quite difficult to actually sample all of them in terms of the reference library. You are actually the expert on this, so you probably know even better than me. And so the idea, since we're mostly interested in what is the behavioral adjustment in the case of modern varieties or that have particular traits, I think that it is way more important to be able to capture probably all the different improved varieties, rather than focusing on all the spectrum of all traditional varieties that maybe have very little variation in terms of the behavioral adjustment that is required to obtain to achieve the maximum yields or disease resistance. Or not sure whether that was a
yeah, no, that makes sense. But then the problem you have is that so if you're sampling according to what the farmer tells you, you sample different parts of the plot to say, okay, this is a particular variety and I call it this, and this is when you're capturing that intraplot heterogeneity to start with, right? You then do the analysis, DNA fingerprinting, you find that 1 out of those 4 varieties that they report is an improved variety. Mm-hmm. They then become part of your adopter group for the second phase, right? Do you know, but then you can't, you're not tracking at the level of the individual plants what then gets replaced or what doesn't get replaced, right? Does that matter? I don't know.
I'm not sure either. I mean, I'm sure. It does probably matter. I mean, it does definitely matter plot heterogeneity. And I've seen some preliminary work, I mean, some work from Frederick actually on how plot heterogeneity actually matters on the sampling, let's say, strategy that has to be developed on this.
Yeah,
I'm really not.
I guess so. You could go from being a situation where they in the first they'd say, okay, we have 4 varieties, and you do the test and you find one of them's improved variety. You go back later and they say again, there are 4 varieties in this plot, and you find that there are 3 improved varieties or whatever, right? But it's that level of change we're talking about. It's not a discrete 0-1 thing we're talking about here.
No, definitely, yeah. That's definitely a good point.
Okay, we have 4 minutes. If there's any last questions, Casey, you had a question about spillovers. Did you want to just touch on that last? If you're still around.
Hi, yeah, sure. Great presentation, Paola. Thanks so much. I'm sure this is something that people who do these kind of information interventions have thought about more than I have, but I'm just wondering, given the timing of the intervention relative to the agricultural decisions in question, whether it's possible that correcting some farmers' misperceptions might spill over and inform control farmers in the same area of things that they had incorrectly perceived, and whether there's a clever way to design the intervention to make sure that it's really localized just to the individuals who receive treatment.
Yeah, I mean, that's definitely a super important thing. I think that we should, I mean, I'm not sure still what is the level of the intervention that is more meaningful to avoid this type of spillover, whether it's kind of enumeration area or a bigger actually area, a bigger administrative kind of size to avoid this type of spillover. This definitely, it's a great point that I need to keep on digging into it. It's thank you.
Well, one thing you might be able to check is in the data you have, you can look for like clustering, geographic clustering in misclassification or misperception, whatever we by village or varietal, and see if like there's appear to be clusters in the data where all farmers are growing, the same variety and also misperceive that variety, such that the information provided to one farmer in that village is going to be useful for the other farmers. If you don't have any sort of I'd be less worried about these spillovers if the geographic clustering is not there, right? Because then probably. So I think the data you have, to some extent, you can kind of look into that.
Thank you. Yeah, that's a great idea.
Okay, we've hit. Thank you, Paula. We've hit time. So thanks to Paula and Kibram and all the participants. Again, sorry for the challenges early on. We'll make sure to get that tidied up moving forward. So thanks, everybody.
Thank you.
Thanks.
Yep.
Fantastic, Paola. Well done.